Consider a charming celestial live performance, an endless collection of astral bodies, suns, worlds, and satellites, all vibrating in perfect accord. Yet within this stellar orchestra, a particular movement has enthralled skygazers for centuries. Exoplanets, those alien realms that exist beyond our solar system, hidden deep within the vast Milky Way galaxy. What might astonish you is that among these infinite heavenly entities, there exists an exoplanet so strikingly similar to Earth, so remarkably familiar that it could very well be our planetary double. Let us embark on a journey into the exciting realm of Proxima B, a planet situated a mere 4.2 light-years from Earth. The James Webb Space Telescope is transforming our approach to the quest for an understanding of these mysterious spheres. Picture, for a moment, your thoughts drifting through the vast astronomical expanse of the Milky Way, harboring more than a quadrillion exoplanets. If you visualize this, imagine each exoplanet being the size of a grain of sand. Not only could this fill the Grand Canyon, but it would also be enough to assemble a brand new geological wonder on Earth, Grand Canyon 2.0, extending 4 million kilometers in length. What is even more astounding is that about 20% of these far-off worlds have been identified as Earth-like in terms of their geological makeup and environment. This means that, for every 5 exoplanets, one may resemble our planet. But the story does not end here. Accompanying these planets may be another quadrillion moons, rocky partners corresponding to Earth's own, performing gravitational ballets with their parent planets. Now that we've begun to unfurl the vast scale of the universe, it's time to introduce the master artisan capable of painting its intricate nuances, the James Webb Space Telescope. This cosmic investigator, with its telescope lens replacing the everyday magnifying glass, outshines even the most state-of-the-art optical devices. Its 6.5-meter primary mirror, 2.7 times larger than Hubble's, enables it to detect even the faintest stellar glimmers billions of light-years away, reading the planets that orbit them. But the James Webb is revolutionary not only for its unprecedented observational power, but also for its advanced technology, which includes infrared sensors and spectrographs. These tools can do more than merely observe. They can scrutinize the specific light imprints emitted or reflected by celestial entities to decode their atmospheric conditions, composition, density, and even mass. Acting as space forensic scientists, they can confirm whether a planet contains water, organic compounds, or even oxygen. The James Webb Space Telescope isn't just an upgraded version of Hubble, it's a monumental leap forward. If Hubble's discoveries left you awestruck, prepare for an even more astonishing series of revelations as we continue to explore the complex terrain of the cosmos. One star in particular beckons our attention, Proxima B. Since its unveiling in 2016, this enigmatic planet has become the protagonist of a cosmic narrative full of intricacy and contradictions that have intrigued astronomers and researchers alike. For starters, it is located in our cosmic neighborhood, just 4.2 light-years away. To put this in perspective, if you could travel at the speed of light, you would reach Proxima B in just over 4 years, the same duration it takes for a presidential term to conclude, or for your favorite television show to become outdated. However, the proximity of this planet is significant for more than just practical reasons. It lies within a universe that spans 93 billion light-years. So locating a planet so close, yet so full of promise for scientific research, is like unearthing a gem in a mountain-sized heap of stones. This gem could hold vital secrets about life and our role within the grand design of the universe. Proxima B's allure isn't solely based on its closeness to Earth. Astronomers believe that it may not only resemble Earth, but could also be Earth's double, Earth 2.0, placed within the so-called habitable zone of its star, where conditions are just right, not too hot and not too cold, potentially allowing for liquid water. Visualize waterfalls cascading down cliffs, vast rivers winding through alien vistas, and oceans as mysterious and profound as Earth's Mariana Trench. However, Before we let our imaginations run wild with thoughts of vacationing on Proxima B, we must consider some of its peculiarities. For example, one day on Proxima B lasts an incredible 11 Earth days. Imagine sunrises that unfold slowly, heralding a new day, followed by extended sunsets stretching into golden hours that photographers dream of. Nature seems to present us with a puzzle wrapped in a riddle. Could Proxima B's civilization be that challenges our assumptions about what makes a planet truly livable? But how can we gather specific, reliable data about a world we have never visited? The James Webb Space Telescope deploys all of its capabilities to address this very question. Operating as a versatile research facility in space, and thanks to its pioneering technology, astronomers can not only observe distant planets, but also analyze them using advanced instruments. Through infrared sensors and spectrographs, the telescope can examine the radiation emitted and reflected by these far-off worlds. By dissecting the specific wavelengths of light absorbed or released by various substances in a planet's atmosphere, scientists can conduct a remote diagnosis comparable to a biopsy on these extraterrestrial domains. This empowers them to evaluate atmospheric pressure, density, and the potential presence of life-sustaining components such as H2O, carbon-based molecules, and even oxygen. The James Webb Space Telescope is not merely another observational device, it is an analytical marvel. It allows humanity to transition from conjecture to verifiable data, broadening our cosmic understanding and reshaping our perception of the universe and of what may exist beyond our terrestrial confines. Just when we thought we had unraveled all of the cosmic mysteries, a startling development surfaced. Researchers utilizing the James Webb device detected something astonishing from Proxima B, a signal so unusual and complex that it rippled across academic institutions and digital platforms, sparking debates about the possibility of intelligent alien life. This electromagnetic transmission was unlike any previously recorded, so particular and rhythmic that it hinted at the possibility of an advanced intelligent source. For a moment, the collective heartbeat of humanity paused, gripped by the notion that we might not be solitary inhabitants of the universe. Yet, as suddenly as the signal appeared, it vanished, leaving behind a haunting quietude, a surge of conjecture, and a trail of unresolved inquiries. Was it just a fleeting spatial anomaly, a brief peculiarity in the cosmos, or could it have been a subtle whisper from a distant intelligence, perhaps a cryptic broadcast, or the lingering echo of a long-lost civilization striving to make contact across millennia? That solitary signal enveloped Proxima B in an aura of enigma, elevating it from a mere object of scientific interest to the epicenter of cosmic fascination. The implications are electrifying. Could this be part of a broader, more intricate saga, one that intertwines us with a larger interstellar network, those certainties to elude us? One truth is unmistakable: the mystery intensifies our resolve. It fuels more than scientific investigation, it kindles an intrinsic human yearning to reach out, to connect with a presence beyond our own.